Yeah. From Smit and Zoon, research and development scientist. Yeah. Sustainable future. Let's hear it. Thank you.
Thank you. First of all, I would like to thank the organization for giving me this opportunity to have a presentation here. Thanks for the kind introduction. And my name is Yujie. I'm currently, as introduced, R&D scientist at Smit and Zoon. And today I would like to share with you our latest development in terms of sustainability and also research. The title of my talk is From Product Passport to Bio-Based, Our Steps Towards a Sustainable Future. So this is an overview of this talk. After a brief introduction on the company and on myself, I would like to focus on the motivation of this work, basically the CSR ambition. And after that, a very brief introduction on the product passport, followed by introduction on the innovation platforms at Smit and Zoon, and finally zooming into one of the innovation platforms, that is the bio-based innovation platform, and explaining what is bio-based, what is biodegradable, and introducing our focus areas, and finally giving you a small flavor of our recent achievements in this respect. And I will end my talk with some acknowledgements. So, for those who are not so familiar with our company name is Smit and Zoon. Actually, it is a family business. It was founded in 1821. We've recently celebrated our 197 years of anniversary. It is still family owned, so which means we are very much looking forward to the next generations to come. And the core business of the company is really leather chemicals. Actually, this is since the beginning of this year, because until the end of last year, we still have a part that is focusing on functional oils, where we started with, focusing on food and feed, but since the beginning of this year, the core business of the company is really leather chemicals. We have a rather extensive global presence with a very strong global agent network, and we also have a few production sites around the globe. About myself, I obtained my PhD in material science from the University of Twente in the Netherlands. And after that, I had quite extensive academic background. I worked in nanotechnology field as well as biomaterials. So actually, my background fits really well into leather science. And I joined Smit and Zoon in 2014. And since around this year, in 2016, I've been leading the bio-based innovation platform, which I will tell you in a minute. So first, let me introduce the motivation of having these platforms and having these innovation activities. That is basically our corporate social responsibility. In Smit and Zoon, we've established the CSR ambition. We would like to play a catalyzing role in making the leather value chain largely sustainable by 2025. And within our R&D department, we are very much focusing on the footprint sub-ambition, that is to become a recognized leader in reducing the footprint in its value chain. So the activities I'm going to talk about are very much focusing on the footprint sub-ambition. So I've shown also a small picture of a red pepper here, which showing that we really would like to catalyzing the activities along the line in the whole leather value chain. So a brief introduction on the product passport. Since the beginning of last year, we've introduced the product passport. What does it do? Actually, it is mainly focusing on current products. So for each product, we have made a description depending on a certain recipe in leather making, what would be the environmental parameters you are going to expect from this product and from a certain application recipe. So in the product passport, we've included information on leather performance, haptic performances, for example, We've listed also environmental impacts of these materials, and we also listed the raw material renewability. For those who are interested in having a look at the product passport, I have actually a sample here. You can come back to me in the break or later on. So, taking one step further, with the product passport, we are very much focusing on current products. We would like to really be more proactive in designing new products through our innovation activities at Smit & Zoon. So since the beginning of 2016, we've established 3 innovation platforms, namely the bio-based platform, emission platform, as well as the uptake platform. And we are really happy to share with you that with 2.5 years of effort, we've established really very pleasant and intensive collaborations with some universities, institutions, as well as chain partners and brands. So, zooming into the bio-based platform, why are we doing the bio-based platform? I've listed 3 reasons here, because we are living in a society, and the whole society is now moving from fossil fuels to biomass. So the bio-based economy makes more and more raw materials with natural origins available, and we think products based on these materials are likely to have reduced footprint, thus contribute to a more sustainable value chain, thus helping us to achieve our CSR ambition. So the second reason is that in the meantime, we are also seeing that the economy is moving from a linear to a circular fashion. So circular economy stimulates a smart utilization of industrial waste streams from biological origin, which is also expected to generate new revenues with added social economical values. And the third is we are very much also looking at not only products, chemical products, to be specific, but also the process of making leather. So we focus also on the improvements in the reutilization of waste generated during leather manufacturing, and we also would like to take leather's end-of-life scenario into account. So in this respect, we are also very much looking at the biodegradable aspects, not only on the chemical side, but also on the leather, on end product. So all in all, summary is that we think bio-based chemicals are expected to have a direct positive impact on reducing the footprint in the leather value chain, and this is exactly the reason why we are doing this. So, having made the decision, we first have to look at a few definitions. So here I gave you a list of vocabulary. What is bio-based? Bio-based means those materials that are derived from biomass. And bio-based content means a fraction of the product that is derived from biomass. And in turn, bio-based product means a product that is wholly or partly derived from biomass. And biomass is the material of biological origin, excluding material embedded in geological formations or fossilized, which means basically petroleum-based material. And in our daily life, we also often encounter the word renewable or renewability. Renewable material, by definition, is very similar to bio-based. Those are material that is composed of biomass and that can be continuously replenished. So here, by definition, it puts a lot of focus on the rapidly replenishment. So rapidly renewable material should have harvest cycles basically under 10 years. And maybe some of you already noticed with product passport, we are using renewability actually to determine the bio-based content of our products right now. So here I'm showing you a concept of the bio-based economy. What you start with is bio-based biomass production. You use biomass that is originated from sustainably available plants, algae, primary residues based on grass cuttings or wood waste, secondary residues, food production waste, for example, and tertiary residues by, for example, household waste. This biomass, they will first go into biomass conversion through either a biochemical or a thermochemical conversion process and made into bio-based products. And here, a pyramid-shaped bio-based product portfolio is shown that with reduced volume, you usually get higher added value. And I've also drawn Smit and Zoon's logo there. Actually, leather chemical, we expected, if they are bio-based, they have a medium volume and also medium added value. So, coming back to bio-based content determination, actually there is an official method because the bio-based content is defined as the material or product as fraction weight or percentage weight of the total organic carbon in the material. And the official method actually points that you should use radiocarbon dating to measure the bio-based content. That is an ASTM method. The basic idea there is that plants, they will absorb carbon from the atmosphere, and carbon will decay with a certain speed. So by measuring the amount of carbon-14 in your material, you can measure the age of your biomass. Basically, the more carbon-14, the younger the plant should be, and thus the more rapidly it is replenished. So as I just mentioned, we have been using, not the official method yet, but we have now an internal method which was also used in the product passport to determine the amount of renewable material that is in the product. So how this is done, we have categorized all raw materials into 5 categories. So whether they are 100% renewable, 75, 50, 25, or 0%, which are generally based on supplier information. And after that, we used a product recipe to calculate the amount of renewable content in the product. That actually was used for the data presented in the product passport, and for the time being is also used in a bio-based platform to determine the amount of bio-based content. Here I'm showing you 2 lists of representative Smit and Zoon products, as well as their respective renewable content. What you can immediately see from these 2 tables is that generally the renewable content of syntans is less than that of fat liquors, and this has the reason that actually from the start of our fat liquor product, we've been using all natural-based oils as a starting material, for example, fish oils and vegetable oils. And of course, this will give you a higher renewable content, and syntans, for the people who knows about the syntan chemistry, many of them are made based on petroleum-based raw materials. The next concept, it is biodegradability. And we have to first look at what is the biodegradation process. Biodegradation is the disintegration of material by bacteria, fungi, or other biological means. And in practice, almost all chemical compounds and materials are subject to biodegradation. And actually the key lies in the fact how fast they are biodegraded. So here I gave you a list of examples showing the different time frame for certain materials to disintegrate. For example, paper towels, which are made mainly by cellulose, will degrade in a matter of weeks. If it is cotton, it will take a bit longer, but plastic bag and plastic bottles will simply take decades or even 100 years to degrade. And if it comes to metal-based materials, it will take even longer. And biodegradability, it is the capacity of material to decompose over time as a result of the biodegradation process. So in order to set the priority area in the bio-based platform, we've turned to a methodology that is used by a company called APEA. They've been working on this methodology, which is really very much fitting into what we would like to achieve. That's why we are working together to set the priority area in this platform. In the cradle-to-cradle methodology, they use three main principles. The first one is that everything is a resource of something else. Material you use are healthy and continuously reusable. The second one is we should try to use current solar income as much as possible, basically renewable energy resource for your production process. And the third one is to celebrate diversity, conceptual diversity, biological diversity, as well as cultural diversity. So it is interesting to point out that through the exercise we did together with APEA, we've come to the conclusion that leather, by definition, should belong to the biosphere. So in cradle to cradle, they generally categorize things into two categories, whether they should belong to the biosphere, whether to the technosphere. So leather, by definition, should really end up in the biosphere. And using cradle to cradle, we've also calculated the material reutilization scores of our product groups. And here you can see we take both the renewable content as well as the biodegradable content into account in the material reutilization score calculation. Actually, the MR score is calculated as such that you add the renewable content with 2 times the biodegradable content and divide the whole sum by 3. So by using this method, you also automatically recognize that biodegradability is actually more valued in your calculation. So generally, with cradle-to-cradle methodology, they categorize the MR scores into 4 categories, corresponding to bronze level, silver level, gold, or platinum. And if you look at our product portfolio in the wet end, you can see that similar to what we have seen in the renewability content, the phenolic syntans has the lowest MRS scores, where the fish oil and natural oil-based fat liquors, they score really, really high already. So, having said all this, as background information and researches we have done with APEA, we have set the following focus areas in the bio-based platform, which are first, increase the renewable content of our existing product groups. As I have just introduced, since the syntans, they score low in the renewable content. They score also very low in the MRS. We've set it as the priority area. So we would like to utilize renewable raw materials as alternatives in, for example, phenol formaldehyde-like condensation chemistry for the syntan product range. And the second thing, you see that the MRS of fish oil and natural oil-based fat liquors are already very high, but they can still be higher. So the second area in this sub-area, in this focus area, is to further increase the renewable raw materials content in the fat liquor range. Second focus area we would like to work on are really new product developments towards the circular economy, or based on the cradle-to-cradle concept. We would like to work on valorization of industrial waste streams from biological origin, and for example, in this case, food production waste, we are also looking at. The third focus area is to improve the general biodegradability, or MRS, of our products. As you have heard, biodegradability is really very much valued in the MRS calculation. And what are we doing to work on this area is basically to integrate biodegradability test to make it a routine task in new product development. So not only looking at the biodegradability of the chemicals we make, we also very much look at the biodegradability of the effluent. Of course, we have a lot of challenges. First of all, bio-based doesn't mean the performance on leather will be better. So by developing these bio-based products, we always have to look at cost, sustainability values, as well as the performance on leather. And the second big challenge is that bio-based is not biodegradable. You already learned from the MRS calculation that these two are taken separately. So we also, in the end, would like to look at the end-of-life scenario of leather because it really belongs to the biosphere. However, we are also keeping in mind that in terms of process, we would like to be smart in designing new products to minimize the complexity of chemical reactions, not only the chemical raw materials we use, but also the energy we consume in making these new products. So we are also looking at taking the full value chain into consideration. For example, the effluent from the leather production. Finally, I would like to give you, as I said, a flavor of the achievements we have so far in terms of real product development. Very recently, last year in September, we filed the first patent application of Smit & Zoon ever on the innovative lignin-based Sintan. In this product or prototype, we've used the lignin, technical lignins, as a partial replacement of phenol in the phenol-formaldehyde condensation reactions. What we can achieve by this new prototype is that we have a product that has an increased bio-based content. It has real retanning effect on leather, and it can achieve, in the meantime, low emission profiles. It has, of course, improved biodegradability and also greatly improved BOD5 versus COD in the leather processing compared to those resulted from the utilization of traditional sintans based on petroleum-based raw materials. With all this, I would like to end the talk with the acknowledgement to the colleagues at Smit & Zoon who have supported me in achieving all this, our partners, and last but not least, your attention. And I'm open for questions. Thank you.